Hello all, today we are going to discuss about JPG 2000 and MPG. JPG 2000 is an image coding system that uses the state-of-the-art compression techniques based on the wavelet technology and offers an extremely high level of scalability and accessibility. Content can be coded once at any quality up to the lossless, but accessed and decoded at the potentially very large number of the other quantities and resolution and or by region of interest with no significant penalty in coding efficiency. JPG 2000 extend the popular JPG standard to provide the increased flexibility in both the compression of continuous tone still image and access to the compressed data. For example, the portion of the JPG 2000 compressed image can be extracted for retransmission, storage, display and or editing. The standard support up to 16,384 components with the dimensions running into the thousand of terapixel and precisions as the high as 38 bits per sample with or without tiling, and with a variety of interchangeable data progressions and random access capabilities. The JPG 2000 architecture lends itself to a wide range of uses from portable digital cameras through to advanced pre-pressed medical imaging, geospatial and the other key application domain. These figures represent the impact of dead zone interval selection on wavelet coding. The first step of encoding process is a DC level shifts the sample of the S size bit unsigned image to be coded by subtracting 2 raised to S6 minus 1 if the image has more than one component like the red, green, blue planes of the color image. Each component is shifted individually. If there are exactly 3 components, they may be optionally decoded using a reversible or non-reversible linear combination of a component. It is represented by I0, I1 and I2 as a level shifted input component, and Y0, Y1, Y2 are the corresponding decorrelated components. If the input components are the red, green, blue planes of the color image, approximate the R dot G dot R dot J dot B dot is equal to Y dash CBCR color video transform. The goal of transformation is to improve the compression efficiency. Transform coefficient Y1 and Y2 are the difference images whose histogram are highly peak around 0. This equation represents the reversible component transform. Y0 x comma y is equal to 0.299 I0 xy plus 0.587 I2 I1 xy and 0.114 I2 xy. Similarly, Y1 and Y2, where I0, I1, I2 are the level shifted input components, where Y0, Y1, Y2 are the corresponding decorrelated component. We are put into the determinant form, that is Y CBCR is equal to values into RGB. This table represents the impulse responses of JPG 2000, that is filter tab 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4. High pass wavelet coefficient and low pass wavelet coefficient for that filter tab. For 0, the high pass wavelet coefficient is minus 1.11 and low pass scaling coefficient is 0.60, where for plus minus 1, the high pass wavelet coefficient is 0.59, where the low pass coefficient is 0.26. Similarly, for plus minus 2, plus minus 3 and plus minus 4. These are all about the impulse responses of JPG 2000. Then this figure represent the JPG 2000 two-scale wavelet transform tile component coefficient notations and analysis gain. The transformation just produces 4 subband, a low resolution approximation of the tile component and that component's horizontal, vertical, diagonal frequency characteristic. Repeating the transformation NL times with the subsequent iteration restricted to the previous decomposition's approximation coefficient produces an NL scale wavelet transform. Adjacent scales are related spatially by the powers of 2, and the lower scale contain the only implicit exactly defined approximation of the original tile component. The notation of JPG 2000 standard is summarized for the case of n is equal to 2. A general NL scale transform contains 3 NL plus 1 subband whose coefficients are denoted AB. For B is equal to NL LL, NL HL is equal to 1 HL, 1 LH, 1 HH. The standard does not specify the number of scale to be computed. To reduce the number of bits needed to represent the transform coefficients, EBUB of subband B is quantized to the value QBUB is using the formula QBUB is equal to sine of ABUB dot floor magnitude of ABUB upon del B. The quantization step size del B is given by 2 raised to RB minus sigma epsilon B 1 plus mu B upon 2 raised to 11, where RB is the nominal dynamic range of subband B, epsilon B and mu B are the number of bits allocated to the exponent and the mantissa of the subband's coefficient. The nominal dynamic range of the subband B is the sum of the number of bits used to represent the original image and the analysis gain bits for subband B. Subband analysis gain bits follow the simple pattern shown in figure. For example, there are 2 analysis gain bits for subband B is equal to 1 HH. For error-free compression, mu B is equal to 0, RB is equal to sigma epsilon B and del B is equal to 1. The extrapolated parameter for the subband B is given by the formula mu B is equal to mu 0, epsilon B is equal to epsilon 0 plus NB minus NL, where NB is denote the number of subband decomposition level from the original image tile component of subband B. This figure represents the JPG 2000 fundamental building block. It consists of encoder and decoder. Encoder consists of pre-processing for intercomponent transform, quantization, tier 1 encoder, tier 2 encoder. And decoder consists of tier 2 decoder, tier 1 decoder, dequantization, inverse intracomponent transform, inverse intercomponent transform and post-processing. This is all about the JPG 2000 encoder and decoder blocks. This figure shows 4 JPG 2000 approximation of the monochrome image. Successive rows of the figure illustrate increasing level of compression, including C is equal to 25, 52, 75 and 105. The images in column 1 are decompressed JPG 2000 encoding. The difference between these images and the original image are shown in the second column, and the third column contain a zoom portion of the reconstruction in column 1. Because the compression ratio for the first 2 rows are virtually identical to the compression ratios, this result can be compared both quantitatively and quantitatively to the JPG transform based result. Finally, we note that the compression achieving row 3 and 4 of figure is not practical with the JPG. JPG 2000 provide usable images that are compressed by more than the 100:1, with the most objectionable degradation being increased image blur. This is all about this figure. The next topic is Y, CB and CR transformation. One of the 2 primary color spaces used to represent the digital component video, the other is RGB. The difference between YCBCR and RGB is that YCBCR represent the color as a brightness and 2 color difference signal, while RGB represent the color as a red, green and blue. In YCBCR, the Y is the brightness, that is luma, CB is the blue minus luma, B minus Y, and CR is red minus luma, that is R minus Y. YCBCR is commonly used color space technique in digital video domain. It is used in image and video compression standards like JPG and MPG. The YCBCR technique is used to show the better view of the image. Let us consider the figure, that is YCBCR for acquired image. In figure, the input images are converted into YCBCR images for Word document image, MRI image and scenery image. First image is for Word document image, second for MRI image and third is for scenery image. After the YCBCR conversion, the images are iterated to separate the in features of YCBCR components such as Y component, CB component and CR component. As shown in figure, the Word document image is classified into Y component, CB component and CR component. In figure, the MRI image is classified into Y component, CB component and CR component. The RGB color space can be transformed to HSI color space as equation. The S value of the HSI color space can be increased, then at last the new HSI signal should be transformed back to RGB color space again. However, the scene image saturation enhancement method is a little bit complicated. Then next topic is MPG. The Moving Picture Expert Group, that is MPG, is an alliance of a working group established jointly by ISO and IEC that sets the standard for media coding, including the compression coding of audio, video, graphics and genomic data, and transmission and the file format for various applications. Then what are the features of MPG? Compared to the most format are smaller in size. Sophisticated compression technique. Compared to most format, superior audio and video quality. Major standards are MPG 1, 2, 3, 4 and 7 and 21. Many simple and cheap decoders. Supported by all popular browsers. Both are non-commercial and cross-browse. High image resolution and multi-channel sound technique. It uses symmetrical or symmetrical compression methodology. These are all about the features of MPEG. Then next topic is what are the features, what are the advantages and function of MPEG. Function of MPEG is storing audios in a compact disc, that is CD, and second one is storing of videos on a digital video tapes. This is all about the function of MPEG. Then what are the advantages of MPEG? MPEG file produces duplicate of the original files which are of very high quality. MPEG files format are compatible with the most web browsers and can run on a various platforms. This is all about the advantages of MPEG. Then next topic is what is the working of MPEG. MPEG follows an algorithm in which the data are compressed into small bits so that they can be easily transmitted and decompressed and then encoded using discrete cosine transform. The compression rate of MPEG is high because it does not store the complete frame. It only stores the changes that has been done to the frames. Hence, it produces the size of overall file. This is all about the working of MPEG. So today we are discuss about JPEG and MPEG in detail. Thank you guys.